Hi, everyone. Jeremy here. Nice to meet you. I am super excited to be here for a bit of a weird reason. The Rust meetup in Paris is the reason why I'm here today. And by that, I mean, because I went to such a meetup 4 years ago, or even 5 years, I don't quite remember. It got me to connect with people who were working at Mozilla back then and working on Servo. Maybe some people remember. And that's why I started learning Rust and doing open source. And now I'm working full-time at Apollo with a bunch of other people focusing on GraphQL. One of them is in the room right now. Feel free to ping him. And yeah, I'm working on building a supergraph runtime in Rust. So some very, very cool stuff with latency requirements, safety critical, mission critical for companies. It's all happening in Rust, and it's all thanks to this meetup. So I'm very, very happy to be here. Today, as was introduced, we're going to talk about rewriting it in Rust. We're going to talk about why you would choose to rewrite stuff in Rust. We're going to talk about how you can rewrite stuff in Rust. Okay? Here's a couple of handles. My name is Jeremy Lempereur. You can find me on LinkedIn. You can also find me on Twitter, X, or whatever the current name is. And if you're looking for another social media, here's my blue sky down below. Hope I don't get banned for this. So yeah, let's have a look at the agenda for a second. Why we choose Rust? When should I use Rust? When should I not use Rust? And that's very important. I hear a lot of companies that says, we tried Rust, didn't work, Rust isn't good. No, that's not quite the reason. We'll dive into it a bit later. And once you decide, we're going to have a look at a couple of migration tips. How do I go from an existing code base with customers delivering value and actually turn progressively stuff into more and more Rust? And then we're going to talk about deploying, maintaining your application. What I mean by that is if you are rewriting an application in another language, you end up in a situation where you need to be able to trust the new code that uses a new language. You need to trust that the rewrite effectively behaves the same as the previous one. And you need to trust that it's not going to break production. How can I safely deploy my new application next to the old one? Okay? Let's dive. Why we chose Rust? If you are familiar with meetups in general, that's pretty much the gist of why people choose Rust. The $1 billion mistake, not here. No null, no throw. The router is not allowed to crash, and it won't. We use options and results for people who are familiar to actually deal with that. Ownership and borrowing means there's a whole class of bugs that is prevented at compile time because the compiler has our backs. Zero cost abstractions, very important. We are making no compromise here. It's not either the code is elegant, like functional programming and this kind of stuff, or it's fast. And the type system is really great. Well, with a bunch of caveats. I don't know if you've heard of GATs, for example, but we're not going to talk about those just yet. Great type system, a lot of elegant abstractions that you can use. The reason why we choose Rust in general, I see a lot of people come for the performance and stay for the safety. Rust is fast for sure, but the reason is that we prevent a lot of bugs at compile time. And what I mean by that is that this chart is pretty well known. It's actually like the relative cost to fix bugs. What I mean by that is how much engineering time and actual company time does it take me to acknowledge the fact that there's a bug and fix it. If it happens during requirements while you are basically at the drawing board saying, hey, we should do this and that, you can say, oh, no, that's not going to work because X, Y, Z. At that point, you're in a pretty good spot. You just figure something else out. It's not going to take a lot of time. When it happens during coding, it's not really great, but it's still fast. And then it's going to be more and more expensive. If another team catches it, then it has to go back to your backlog. It has to be a bug. You need to switch context. You need to work on that. It's terrible. System acceptance testing, and the worst thing is after the release, of course. After the release is basically when your customers call you to tell you that there's a bug in your software. Doesn't feel good at all. We're trying to shift left as much as we can, and Rust helps us achieve that. When should I use Rust? I used to do freelancing before I joined Apollo. Most of the places where I saw widespread usage of Rust were basically when security is critical. It doesn't happen to most of the companies, to be really honest. Like when security is really critical. In constrained systems, what I mean by that is embedded software, your headphones, for example. You don't have a lot of memory. You don't have a lot of CPU. You might as well use a language that is extremely fast and that is not going to require a lot of RAM, for example. And at scale. What I mean by at scale is that if you're cloud native, at some point, your AWS or Google Cloud bill is going to be massive. And at that point, the simple fact of rewriting bottlenecks or pieces of your stack in Rust is going to yield tremendous benefit. A small performance increase means a lot of dollars less to pay to in your cloud bills. When should I not use Rust? Well, for the grand rewrite, I hinted at it. The grand rewrite, you know, this big project that is supposed to be exactly ISO, which is exactly just like the previous one, except better and different, but you don't have the specs and it's going to take 18 months. And it's just not going to happen. And if you rewrite it in Rust, it might be even worse, actually, because you need to figure out how Rust works. And you need to figure out what you're building. It's going to be very hard. You're going to stop delivering value to your customers and to your users, which is ultimately what you're here for. You're not here in a company to actually have fun with the tool. You're in a company to provide value. You can't halt it for 18 months for a grand rewrite that is extremely risky and might not happen. Or if your team can spend time learning it, use a language that you are familiar with. I don't really like Go. I used to write some, but I don't really like it. One thing that I really like, however, is that it takes around 3 hours to switch from another language to Go. It's much easier to learn Go. It compiles extremely fast, especially compared to Rust, and you are in a great situation if you use it. So sometimes Rust is not the right thing to do. Okay, no one stood up, so I guess you're still here. Let's see how we can rewrite stuff in Rust then, and how we made it. Basically, what we did is an incremental rewrite. What I mean by that is that at Apollo, there was a lot of JavaScript and TypeScript. The gateway that the Rust router is replacing was written in TypeScript and JavaScript. So we used something that is called Deno, or is that Dino? Not sure. Anyone familiar with Deno? Can you raise your hand? Okay. Not too bad. Which is pretty much kind of like a JavaScript runtime, except it's written in Rust, and it allows you to run JavaScript or TypeScript code. So basically, we use Deno, and we interface from Rust into JavaScript. And the deal here is that you can interface with most of the languages, and you can reuse the tooling, the libraries, and everything that you're comfortable with. It doesn't have to be a leap of faith. You can adopt it incrementally. You identify the places, and then you migrate. Most of the router functionality that I said is written in Rust. And the query planner, which is the only part at the moment that is written in JavaScript, well, which is written in JavaScript or TypeScript, we interface with via Deno. Okay? Here is the biggest TypeScript sin I've not written, displayed on a screen. We basically declare something. Please do not make it the any type. That's just for the purpose of the presentation. And then you use it. That's pretty much what you have in the TypeScript code. Then you have a couple of lines of code that say, hey, by the way, my hello.js file is right here. You create a worker path, you instantiate a worker, and there you have it. You're running hello from Deno directly from your Rust code. Okay? It's not too complicated. Let's do a bit more JavaScript, since that's what you're here for, right? Basically, what we have here is a while true. So that's pretty much a loop. And we are receiving events that come from Rust, and we are sending responses back to Rust. That's pretty much how we write a small worker using that. And then you can use it. It's extremely powerful, and you can invoke and call stuff back and forth from Rust to JavaScript. Like I said, a couple of strategic tips. You identify bottlenecks. First of all, you need to have a reason to rewrite stuff. Then you rewrite piece by piece. The good news for us is that most of the code has been rewritten in Rust already. And now we are going to start trying to rewrite the last tiny bits. How do you trust the code? How do you make sure that your rewrite is actually doing what it's supposed to? Here's a couple of pointers. Not a good pun, is it? The first one is unit tests. Everyone familiar with unit tests in general? Yes, 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 yes. Okay, that's going to be fast. There's a second class of tests that we rely on very heavily, which is called snapshot test. Does everyone know what a snapshot test is? Okay, pretty cool. Let's have a quick look at an example if I can find it. Yeah. Here we have a couple of tests that actually rely on snapshots. The snapshot, which you can see here on the left-hand side, is the expression, the line at which it was invoked. So here, this is a GraphQL schema, and it's pretty much dumped straight as a snapshot, okay? The idea is that when I run cargo test, tell me I compiled before, yes. It's gonna run everything and everything is fine. Now the thing is, if the snapshot changes, or if I failed my refactoring, or I changed something in the logic, the test is going to fail. And it's going to tell me exactly, like, it used to be product 2, now it's product. Was this change intentional? That's basically how you can write tests using snapshots. It's extremely useful for 2 reasons. Regression testing, making sure that you did not break anything when you were refactoring your code, or for our example, that the previous code behaves exactly like the new code. But we can go a bit deeper. There's one thing that is called code coverage. Has anyone used code coverage yet? Yes, yes, yes. A lot of yes. That's really good. There's a crate, I think it's called Cargo Tarpaulin. Is that spelled correctly? Pronounced? I don't know. This crate is really good. It actually instruments your tests. They take a bit longer to run, but you then get a nice output with a view, and you see all the lines that are covered by your tests. It's really nice. It gives you a view that's kind of like that. Sorry, I can't zoom, but basically you get the colors. It says that the code coverage in the router is pretty okay, except the folder, but well. And it's super useful. Pro tips for that. You want to aim for 80% coverage. Hunting for 100% and hitting all code path is just going to be a time sink. It's going to take forever. Honestly, you don't need that. 80, 90 is fine. Less than 50, 60 is a bit low, to be honest. And the other thing is that it doesn't prevent you from writing bugs. It just makes sure that you wrote the test that actually covers what you expected. So it's not great either, right? One last thing that is very important. Yeah, you get a rough idea. So it's just a helper. You run it once. Maybe you put it in CI sometimes if you want to. But honestly, you get a rough idea of what parts of your code base is covered, and that's it. One thing that's very important, you don't want to use it to point fingers at your teammates. It's a bad look. You are all working as a team, okay? Seriously, don't. Do not do that, okay? Yeah, he's probably going to make me pay for it. This is Geoffroy, maintainer of Num, by the way. I hope he doesn't watch this. One of the other things is called fuzzing. Anyone knows what fuzzing is? Yay, that's amazing. So fuzzing is pretty much when you write a test, you cover the path that you had in mind, or you cover the situations that you could figure out. Sometimes there's just too many situations, and it's going to be extremely hard for you to figure out all the possible inputs that you can feed into your function. Fuzzing is a way to generate tests based on some random input and just feed it into whatever your application is. We're going to have a small look at what it might look like. So here, and I'm going to zoom a little bit as well. Here I have a router that is running real quick, which is right here. It's basically a GraphQL API, so I'm going to send a bunch of GraphQL queries in it. And I also have something else that is hidden right here, and I hide it because it's Node.js, which is the gateway, like the old code, okay? And what I do is we have a couple of fuzzing tests that here generate operations. And generating operations is pretty much the process of turning garbage or random input, like /dev/random, into a valid operation. It basically goes through all the code path. If there's like an enum or whatnot, it's gonna convert whatever the input that is random is into a structure, and then it's gonna feed it into whatever you want. Here, we are doing something, as you can see, we are creating an HTTP client, and we are calling the gateway. We are calling the router, sorry, and we are calling the gateway. Then we have some debug output. We are checking the response, the status codes, and we are making sure that, can I see it? File write-all, file flush. So in case of error, we are going to dump it. So we actually have a reproduction test cases. And we are going to check errors, and we are going to check output. That's an extremely powerful tool. And I hope I'm not going to bork my computer if I do this. You need to run nightly, if I recall correctly. And you run a fuzzer, and you're going to get a lot of output like this. And it's going to run. At first, it's going to crash almost immediately, because it's going to figure out cases you did not have in mind. So you're going to fix them. And the way it's going to do it is it's going to show you the crash, and it's going to give you a reproduction case. From the input that it has generated, it's going to dump you all the steps to reproduce, so you can actually trigger the crash. You can turn it into a test, and you can fix it. And eventually, after a while, it's going to be able to run for a bit longer. And I'm going to cancel my demonstration right here, because I do not want you all to see the router crash. Oh, it just did. Interesting. I have a reproducing a case that I can reproduce. If I run this command, I can reproduce this exact test case with the bug. I can minimize it. It's going to take a bit, and it's going to figure out the smallest input it can give us so we can actually reproduce the bug. Super interesting. I'm going to keep this window open just in case it's not a demo and I actually crashed the router, right? And the last thing that I wanted to show you about fuzzing is right here. So this is even smaller, I guess. So I'm going to zoom in. This is a trophy case. The trophy case is a showcase of bugs found via Fuzz testing. Super interesting to have a look at. A lot, and I mean it, of crates rely on it to provide you with the most stable code they can. And you can see a lot of either security issue or panics or bugs that have been found by the fuzzer. It's an extremely powerful tool. I highly recommend you to use it. So in order to trust the rewrite, we need a common suite of test cases. Yeah, just not black. Sorry. We need a common suite of tests that applies to both code bases. Ideally, you have started your migration by writing integration tests that apply to your previous application. Given this input, I get this output. Once you have what is called like a test harness or a safety net, it's going to become much easier for you to start the rewrite, because you know you have acceptance tests. You know exactly how your thing is supposed to behave. And once it behaves as expected, git add dot, git commit -m done, git push, and you put it in production. Not quite. But we're getting there. Another thing that is very interesting, but that's more for the opsy people. Anyone familiar with Kubernetes? Wow, that's impressive. Honestly, I should just drop the mic. Everyone knows most of the things that I'm talking about. That's really amazing, by the way. Traffic mirroring is a feature that allows you to pretty much mirror all the incoming traffic to several places at the same time. It can be very useful. You actually send stuff to your production, and you send stuff to the new. And then you can check whether the response actually has the same shape. Try not to do that with mutations, or try not to do that with the production database. If you insert rows twice, it might not lead to a great outcome for you, but you be the judge, I guess. Another thing that we do is validation with feature flags. It's something that we recently did in the router. We basically have some GraphQL validation that is running in JavaScript, and we rewrote that part in Rust. And in order to make sure that it actually behaves as expected, we have a bunch of feature flags that can be configured for the router, where you set validation to JS only, Rust only, or both. And if you have both, we can actually identify cases where it doesn't behave exactly as expected, so we can cover them and gain more trust. This is why the section is called How to Trust. It's not about bugs or not bugs. It's about others understanding that the level of quality you bring to the table is enough for them to trust you and your software. Tech is never about tech. It's about people. It's about them understanding how much you value the quality of the work and how much they should trust you. Okay? So feature flags, super useful. There's probably another way to test with that, but I might get to it later if I get enough time. The third one is how to trust we will not break production. Yeah, I just shipped my software. I'm very happy. Some SREs are responsible for actually dealing with prod might not be too happy when they get paged at 3 a.m. on a Saturday after a couple of drinks. Okay, let's not do too much. Telemetry. There's one person right here who could talk a lot about telemetry. Yeah, I'm talking about you, Luca. I'm not gonna dive into it too much. Basically, you can add observability using the various tracing open telemetry crates that you get from the Rust ecosystem. It's a bit of setup, I'm not gonna lie, but once you get it right, it's extremely helpful. Then you can feed all of that into your tiered environments. What I mean by tiered environments is pretty straightforward. Dev, staging, sometimes pre-prod that hopefully kind of looks like prod, but it's not quite the same, and you figure it out sometimes when your production crashes and you don't expect. And then production, okay? You test in lower tiers, you add all the features that you're gonna use in prod, and you observe the behavior, logs, spans, telemetry, metadata. And once you have confidence in the lower tiers, then the SREs are gonna come to you and say, hey, when do we ship it to prod? That's when you win. And dashboards and alerts. I don't have any recommendation as to how to set up dashboards and how to set up alerts. We personally use something that is fairly expensive. It's a brand that barks. I'm not gonna give more details, that's probably enough. And the last thing that I wanna touch on is progressive rollouts. There's a really great feature in Kubernetes that allows you to set up. So at the ingress, an ingress is pretty much what gets the traffic from outside and routes it inside to various applications. There's a features that allow you to say, I want to route 0% of my traffic to this application and 100% to that one. And then you do progressive rollout. You progressively turn the knobs so you send 1% of traffic to your new app, and then 2, and then 5, and then 10. And if anything goes wrong, you just roll it back to 0. And you keep working on that, and you can do it in lower tiered environments and then to production. That's how you do it. About progressive rollouts, there's one more thing that we use that is sometimes very helpful. There are features which are present in the router that were not present in the previous gateway because we iterated on that and we built new things on top of it. We also have a feature flag that is for clients using something that is called Launch Darkly. Do you know Launch Darkly? Cool. Launch Darkly is pretty much before you do something like A/B testing or something, you're going to call Launch Darkly, you're going to ask, give me the percentage or the ratio for this specific probe. And it's going to tell you, yeah, that's 50%. Okay, then you're going to roll the dice. And if that's below the 50%, then you're going to hit endpoint A. If it's above, then you're going to hit endpoint B. Now, what we're using it for is not for rollouts like what we said about Istio and turning the knobs to switch traffic from the gateway to the router. We actually use it as a flag that is called router in production. This flag is either 0 or 1. So the clients will know whether router is in production or not. If it's in production, they can use all the fun new features that we have provided. But if we need to roll back to the gateway, we can just set the flag. The clients are going to stop relying on features that are not available in the gateway, and we can safely roll back. That's pretty much what we are doing at the moment to make sure that if we ever need to pull the knob, we know how to do it. Doesn't mean that there's a bug in the router. It sometimes means that it's 3 a.m. I got paged. I have no idea what is happening. Just gonna revert. It's not too bad. We'll see on Monday. It's just fine. Okay? And that's pretty much it for me. If you have any questions, feel free to use this link or the QR code, which you hopefully took a picture of. And thanks, everyone.
So first one is from Amin, which says, so you showed before that you were invoking Dino from Rust, and he asks, is there any serialization or deserialization cost when you're trying to do Rust to JavaScript, JavaScript to Rust interop?
There is a cost. There is a cost to it. The reason why we went with that approach, well, there are two reasons why we went with that approach. The first one is that this specific step that is called query planning, which is kind of like, you know, in SQL, when you write explain plan, when you write a query, it kind of shows you what needs to happen to actually satisfy the query. That's pretty much what we do. We create a query plan with the sequence of HTTP or GraphQL fetches that need to happen to actually satisfy the incoming request. This query plan generation is a lot of logic. It's a lot of code, really. And in JavaScript, the way it's written is with a lot of circular references and dependencies. I don't know if you've done enough Rust to write trees and circular references. It's probably not the easiest way to start. The second reason why we chose to keep that part of the code in JavaScript is because the result, the query plan for a given query is always the same. So instead of spending like 6 months to rewrite that part for something that can actually be cached, it's just not worth it. So we went away and we were like, okay, what are the parts that are actually in the hot path that will make us successful? HTTP, input, processing, all of that, that's where it matters. The rest, we let JavaScript do the work and we cache it. Doesn't mean we're not going to rewrite the query planner, as I hinted. It's something that I'm very excited about. But yeah, that's pretty much it.
Related question. You mentioned at the beginning that you don't have to necessarily choose to go all in into Rust, so you can adopt a progressive rewrite pattern, as if in this case. Does the fact that you have two languages in the same code base actually increase the difficulty level of getting started with Rust compared to just doing a Rust code base?
That's a really good question. I think it does to some extent, because of course we need to create all the tools or reuse the tools that actually allow us to interface back and forth. But the good thing is that we could reuse the same code, and we have been able to lean on the same people who were working on that code and who actually understood what was happening, independent of what language it was written in. So that was certainly a plus. Another thing is that it really depends on the way you slice and dice the job to be done. I know that, for example, in Firefox, they started at the leaves. And by what I mean by the leaves is that they didn't start with the core of the engine. They started with like the bits and bolts for networking or input processing, this kind of stuff. That's where the value is. That's where the safety is required, because you can't just parse garbage and expect that everything is going to be fine. And if you really think of the parts that you want to rewrite and you start small, then yeah, you will pay a small cost at the beginning, but it will then set you up for success instead of just rewriting everything greenfield, especially like for huge work, like years and years of work. That's probably not going to work out just fine. And the other thing is that while you are rewriting the small parts, the rest of the code remains in your favorite language or the language that you are used to, which means people can actually keep delivering value on top of it. And that's really the main point. You do not want to stop your project, stop your efforts for the grand rewrite. So it's worth it, in my opinion.
Okay. A few more questions popped up. Some are quite interesting. First one, so when you do a rewrite, obviously, you usually try to match existing functionality, but you're also testing the logic again because you're going through it, rereading the code, rewriting it. Did you discover any subtle bugs in the original version of the gateway? Or not so subtle? That's also fun.
That's a good question. We did find differences in behavior, and we did sometimes not know how to resolve it. What I mean by that is sometimes a test would fail, And we'll be like, is that a bug in the router or is that a bug in the gateway? We are very thankful to be working in a GraphQL ecosystem, which means there's a specification and there's behaviors that are defined. I sincerely hope you have specification at work. Sometimes it's not the case. The good thing is that it actually starts the conversation. It's not about talking to other engineers. It's about talking to product sometimes. Do you actually want it to behave this way? It used to behave like that, but it looks odd. What do you think we should do? That's the right conversation to have. The other thing is that that's the sort of things that we kind of found by using fuzzing. Because we are comparing the output between the router and the gateway, sometimes the router would crash and sometimes the gateway would do something really weird. So it kind of helped us improve the quality of our Rust and improve the quality of the previous application, which was still running and is still running at this very moment. So it's really a win-win. As soon as you start having this conversation, I'll go even beyond that. The reason why we write snapshot testing is sometimes that we don't understand what is happening in there. We give a bunch of input, get some output, we store it, and now we start refactoring it. You can't be scared of a part of your application. You are responsible for maintaining it. There's no way you can be like, I can't touch it. I don't know what it is. I'm super scared. I'm not touching this part of the code. No, it is actually your duty to understand how it works and refactor it until it works the same and you actually understand what is happening. So that's another really good way to have the conversation, understand your code base, be that in Rust or anything else, honestly.
One last question, and then we're gonna just let you breathe. So you mentioned at the beginning that you went with an approach of, let's look at the gateway, let's look at what it's doing, and where can we add the most value by rewriting a component, a module, a subset in Rust. What tooling did you use, or I imagine profilers did you use to find out those portions? Like, how did you come up with the strategy?
So this happened before I joined. So I'm just gonna say some random stuff. Do not believe me. No, basically what happened is that one of the reasons why the company decided to switch to Rust is that we needed the gateway to scale better. It needed to process more queries. It needed to do a lot more. So we knew the limits and we identified the bottlenecks. And to be very precise in this case, basically we had a Node.js server, which is really good at I/O and async stuff. That's really great. But then there's a lot of dealing with JSON, traversing trees, doing some computation. This is CPU bound, okay? This doesn't work extremely well in Node.js. It has to do the work, it hogs the CPU, and there's no room to do something else. And at that point, we were like, okay, what is the most CPU heavy parts of the gateway? Well, query planning. Yeah, but query planning we can actually cache. Okay, what's the next heavy part? Well, gathering the HTTP outputs from all the subgraphs. So a query comes in, we make a bunch of HTTP calls, we gather the output, and we do a lot of mangling here. Okay, so this is the part that we actually want to focus on. Let's see what it would give if we used a web framework in Rust and started doing a bunch of JSON operations. Let's compare that. Let's see if we can optimize it a little. Let's say the difference. Okay, there's a huge perf boost. Let's go for that. And that's basically how it started. And that's pretty much the strategy. Identify, profile. And once you have profiled or identified the various places where you can expect great outcomes, you go ahead and talk to others because you don't want to do it on your own. And that's, yeah, that's pretty much what we did, I think.
Well, that's one real question from the audience, which we're going to take.
Sure. Thank you for the talk.
Sure.
You didn't talk about the interrupt between JavaScript and Rust. Is it WebAssembly, ABI?
Yeah, so is it WebAssembly or ABI? So at the moment we're interfacing through Dino, and Dino is written in Rust. So we basically have a library that exposes Rust primitives. And it runs TypeScript within the runtime. What effectively happens is that Dino interfaces with V8 and isolates. I don't know if you're familiar with it, but it's basically going through the whole V8 pipeline under the hood. That being said, it's very interesting because parts of the router, there's a part that is called the Apollo compiler, which is basically parsing queries and doing validation, this kind of stuff. It also exists in JavaScript, but there are also clients using Kotlin, Swift, JavaScript, or React, or whatever. It would be nice if we didn't have to do all the work twice. So we are considering having like WASM support for this specific part so that people in other languages can actually rely on it. And there's like one source of truth, one implementation that actually satisfies everyone. And that is hopefully going to be fast.
Cool. Well, one last show of hands for Jeremy.
Thank you.